हेलो एवरीवन, वेलकम टू अनदर वीडियो ऑफ जेन एआई सीरीज। आज के वीडियो में हम लोग ट्रांसफॉर्मर्स की जर्नी और उसके प्रीवियस वर्जन के बारे में समझेंगे। हम लोग समझेंगे कि व्हाट वाज द नीड ऑफ क्रिएटिंग द ट्रांसफॉर्मर। पुराने मॉडल्स या एनएलपी के जो एग्जिस्टिंग मॉडल्स है उसमें प्रॉब्लम्स क्या है, उसमें इश्यूज क्या थी जिसके कारण से ट्रांसफॉर्मर का डेवलपमेंट हुआ। So generally NLP has been used for the sentiment analysis, also for the text tagging. So the model associated with the NLP, natural language processing, used to give the output in a specific class or in a specific model. But in case if you need or you need an output in a very complex format and also in a very varying length, in that case the existing NLP model will be not helpful in generating this kind of or varying length kind of output. Nowadays, most of the tasks required more complex output of the varying length. So in this kind of complex scenario, the existing NLP model will be not helpful. So we have to move to some other part or some other architecture which is now used in the generative AI. For example, if you want to look for the language translation from one language to another language, so in this kind of scenario, the existing NLP can do some kind of solution, but it cannot solve the fully in a proper way. So we have to go with the generative AI solution, and the transformer is one of the solution which is used in the Gen AI to use for translation, for the text summarization, also for the code completion. So there are different models inside the transformer. For example, GPT, it's a generative pre-trained transformer which is used for code summarization, text summarization, code generation, and other answer and question stuff. We need to understand the evolution of NLP model from n-gram to word to wake model, and we need to understand and examine that what are the shortcomings, what are the limitation of the existing and NLP model which led to the development of transformer. We'll start with n-gram model and we'll start with one case, and we'll understand that what was the limitation and how word to wake comes into the picture, and then how the next model comes into the picture. So I'm taking an example of autofill tool. In the autofill tool, the tool itself will tell you that what is the next word to come into the picture. For example, there is a word called "it's raining. I need to take." So then the model, you should predict that the umbrella should be the next word. So how the model predicts that umbrella has needs to be the next word? It's by predefining on the data, the how much of the relevant data you feed for the training, the more accurate your model will be. So in word in n-gram model, we are or the model looks into the probability. It has the predictive model which looks for the probability of each word. For example, it's raining, I need to take. Now, depending on the training data, the model will have multiple options. For example, it sees that umbrella comes 100 times. In this kind of scenario, leave word comes 50 times. So it will create the probability of this word. There can be multiple words in a normal scenario. If we feed it to n-gram, there can be multiple options and also the training data which will give into it. So for example, umbrella gets 100 times, leaf comes 50 times. It will create a prediction, or it will create a probability matrix. The model will create a probability matrix, and umbrella's probability matrix comes to the highest level, or it gives the highest output. Then the model will predict umbrella as the next word. So in this way, n-gram works. It is getting trained into the by multiple data input source, and as per the source, it looks for the output. It creates the matrix, probability matrix, and the word which lies on the top of the probability matrix get as an answer, or they get as a predict answer. So biggest issue of this model was that that model was not able to understand the semantics or the context of the language. So for example, if I write the word it's raining, I need to pick. So it will not tell you that you need to pick umbrella, because it has been trained into or it has got the probability matrix. It has created a probability matrix for the word it's raining, I need to take umbrella. So the take and pick, it will understand these two words as a different word. So it will not understand the semantics of these two words as the same, and will give the output as umbrella. It will get confused, and it will again create the probability matrix and look for some other word. So in this kind of scenario, there is a bigger issue in this n-gram model. So there is a more advanced model for that, in which model can understand the semantics and then give you the or predict the answer for you. So this model is word to vec. So it is generally written as word to vec. Vec is for vector. Generally, this model creates the word into a vector numerical unit, because your computer or the model will understand the word as a numerical things, mathematical number. So each word is created into a number, and accordingly, the number decides the what you call importance, or it decides how this particular word is closer to the other word, or what distance the word is from the other word. We'll look into it now. So for example, there is a word called king. So king, this model will give some number in a matrix format, in a different way, or in a different dimension. For example, for the king, it has given some number x. So that is a vector for that king. Now the for the queen, it will give some number. It will create a vector for queen, and as per the training of the model, it will create a distance between these two word. It will create a distance between these two vector. So to calculate the distance between these two vector is done by Euclidean distance. We call it a Euclidean distance. And if the two word is very similar, or they are used in more of the in more of the sentence together, so the distance, vector distance between these two word will be closer. There will be less distance. For example, the vector distance or the Euclidean distance of the king and queen will be less as compared to king and oranges, because these king and oranges, it doesn't make sense goes together. So the Euclidean distance, the distance between the two vector of one king and the other orange, will be more. So in this way, word to vec can understand like which word is similar. For example, in our previous example, the engram was not able to understand that take and pick was the same word. Like we are going to assign the same meaning, or the sentence is going to tell the same meaning for the word take and pick. But that thing has been resolved in word to vec model. In this architecture, actually, the vector for the take and the vector for the pick will have the very less Euclidean distance, and the model can understand that take and pick are the similar words. So if in the case of take it predicts umbrella, so for the case of pick also it will predict umbrella. So that issue, the semantics issue, has been solved in by word to vec. But there is a bigger problems. For example, there is some limitation. The limitation is like, for example, bats, bats, bats. So the bats can be an animal, the flying animal, and it can be the cricket bat. So in this case, the word to vector is not able to understand the meaning. The bat's word is used in which context. So the semantics things has been resolved with some limitation in word to vec, but the contextual thing has not been resolved into this. Now, if there is something like your model is giving the review for the movie, is a positive movie or a negative movie. If someone is putting the question in a sarcastic remark, in that case, word to vec will not understand that context. It will go by the word. If good is written, that means positive. If bad is written, that means negative. But there are some sarcastic remark in which you can write good review, but actually that is a negative review. So that kind of contextual meaning, the word to vector is not able to understand. So then we have another model which is more advanced, where we use where we try to solve the semantics also and all the contextual problem statement. So that model is encoder and decoder architecture, where RNN architecture is being used, and that will bring more information or more quality into the language translation, which we'll see now. So now we'll discuss about encoder and decoder. So the encoder decoder architecture, it uses basically in the background, it uses a recurrent neural network, so RNN. So RNN is specifically for dealing with the text, the continuous text, long sentences. So encoder and decoder, we have two part, encoder and the decoder. So encoder will convert each word into a vector with the context with that, and decoder will use that final vector to predict the answer of which all tasks you will perform on this. So for example, I'm taking a sentence, this movie is good. So I expect the model to give as negative and positive, 0 for negative, 1 for positive as an answer. Like, is this movie a good or not? So this movie is a good. So what encoder will do? So from here to here. So one, two, three, four. These are the part of encoder. So what encoder will do? It will feed like one by one, like this. It will take first word this, and it will feed to one of the RNN cell. We call this as a RNN cell. So this will goes like this. So this will be fed to this. Similarly, movie will be fed to another. So first we'll see here. So this will be fed to this cell, and initially all the weights will it will give a weight. For example, W is a weight given to this. Now it will analyze the context, and that context will be passed from this cell to this cell with the word movie. So movie is the next word which will be passed to the next cell, RNN cell, with the context from the first cell. So how it form, it understand the context and everything, that is a different topic. We need to look into that model. We need to look into how it has been implemented in Python or in some other language, and then we can understand what is the value, or how mathematically the context is being processed. So for the understanding purpose, what encoder is doing, it is taking the first word, like this is the first word for this is good, this movie is good, and this is fed to the first RNN cell. Weight is assigned, W is assigned. Weight generally means the importance of that word at that current point of time. And then context, at what context this word is, and that with the context information, and the next word is fed to the next RNN cell. So this will be fed to this RNN cell. Similarly, a next context will be formed, and this context will move with is the next word to the next RNN cell. So this will finally give a final vector. So it will finally give you this vector. Okay, and this is a vector. You can call it a final vector. Okay. Now from this to this, we can call it as encoder, and this is your decoder. So you see the initially all the cells inside the encoder has a weight W. So initially the model gives, or the encoder gives the value W, same value to each of the word, and as per the answer is correct or wrong, as per the model data it gets trained, or as per the feedback the model gets, it changes the weight, the value of weight. It can increase the weight of W for the movie cell, or it can decrease the weight of W, this cell, for the cell which contain this, and it will try to predict the more accurate answer. So that's how the encoder decoder architecture work. So what the final vector this is formed, this gets feed into the decoder. So here it gets feed into the decoder, and decoder predicts the answer as negative or positive. So it will uh, predict the answer positive or negative, depending on how this model is being trained, how this weight is being distributed. So this decoder will use feed forward neural network to get the answer, or to predict the answer as a positive or negative. So here the context of what was the issue which we had in word to vec, the contextual information or contextual understanding was missing in that model. That has been solved here to good extent. Like the movie is good. So this good word is in context with what, or this movie is in context with what. If I use some satiric or something sarcastic word after this, then it will understand the sarcastic word in this context by changing this value of w. So earlier we have used each word in word to vector, and we were not giving the importance of the word. We were giving the importance of the Euclidean distance, the distance between the vector distance between the two word. Here we are giving the context. We are giving the importance of the w, plus we are generating the context which is moved to the next word. So encoder and decoder is very successful architecture, and this helps in solving most of the sentence translation, text summarization. But it has a limitation. The limitation is when we have a very long sentence, you cannot have all the information like word 1, word 2, word 3, and then move into the final vector. Because in a long sentence, the importance of the one word will not be dependent on the context of the previous word. For example, I'm just writing a very long sentence. So maybe while writing the long sentence, the last part of the sentence can have the meaning totally opposite of what I have written in the first part of the sentence. So in that case, this encoder decoder model will fail, because it will not look for the context or the last word context. It will be not fetched from the first word. It will be fetched from the just immediate back of the last word. So for the long sentence it will be not helpful, but in most of the cases this architecture work. So for the removing the long sentence limitation, the contextual limitation for the long sentence, transformer has come into the picture, in which there are multiple ways in the architecture has been changed so that it understand the context not only from the previous word but also from overall sentence. So that we'll see in the next part of the video. So we saw that how the neural network model, NLP model, from word to vec or n-gram to word to vec, then encoder and decoder, it moves into, there are multiple encoder decoder architecture, there are multiple implementation of it. So if you want to know how the encoder and decoder is implemented in Python language, that also I can show you in the next video. So if you are having any doubt, I know this is a bit a complex topic. If you don't have the background of NLP or some background of deep learning, then it becomes difficult. But if you find anything logically you're not able to understand, then try to post it in the comment. I'll try to solve it, and we'll see the more into the transformer architecture and the implementation, the use case of it in the next video. फिर मिलेंगे नए वीडियो के साथ. किसी भी तरह का डाउट है तो प्लीज़ कमेंट पे पोस्ट करें. थोड़ा कॉम्प्लेक्स टॉपिक है, बट विल ट्राई टू सॉल्व इट बाय मल्टीपल डिस्कशन. तब तक के लिए अपना ख्याल रखिए. टेक केयर एंड गुड बाय.